All right, so let's go to this idea of having a negative be a part of the A value. What does it do to the overall graph? Because so far we've talked about the shifting of the C value, how the positive moves it the whole graph up that many. And if it was a negative, like back here, it's going to shift the whole graph down that same amount. And then we've also talked about how if we change the A value, such as this one here is a 2, it has a stretching. And in the last video, when it was a 1/4, it caused it to widen, or known as a shrink. So the only thing we have left to really talk about so far is to discuss what does the negative do? What does the negative do? And we saw this a little bit in 8.1. So now we're going to go just a little bit further with it. So far, I'm going to say this for transformations. We have a translation. That means that's sliding action. Translation up, because it's a +4. So it's up 4 units. Units. There we go. But what else do we have? We have to figure out, what does this negative do? And we've seen it a little bit already. So I've already went through and done the math for plugging in all of these values into this equation. So in for the x, I've already found all of the values. So I'm just going to go through and plot all of them. Feel free to check out how I did that. -3 squared is a +9, but we have to multiply it by a negative on the outside, so that's a -9. Then +4 is -5. Feel free to do it all through all of those ones and check them. But I'm going to go ahead and plot them. I have to go backwards 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. There we go. It's going to end up right there. Now the next one is backwards 2, and it doesn't go up or down at all. It's a 0, so I just go backwards 2, and then it's right there. Then the next one is a -1, and I go up to a 3, +3, so that's right there. And the one after that in blue is a 0, which means I didn't go left or right. I just go up 4, which is right there. The next one in red is 1, 3. So I go forward 1 and up 3. After that, it's kind of a teal color. I don't know. It's forward 2 and right on the axis, right on the x-axis. So it's right there. And the last but not least, the forward 3, and then I have to go down 5, which ends up right there. So I have that as my parabola when I connect the dots. So first off, did the +4 happen? Well, yes, we see it shifted the vertex up 1, 2, 3, and 4. Now, the only difference between had it been x squared plus 4 is, notice that it's upside down. That is the key idea for what happens when there's a negative. When the A value is a negative, it turns the graph upside down. So the last transformation that we're talking about is, and they call that, it's flipping down, is really a reflection over this x-axis. So really, actually, this negative happens first. It takes the parent, it flips it upside down, and then it shifts it up, the +4. So they call it an x-axis reflection. Now, we haven't really been talking about the increasing or decreasing on the other 2 videos because they were pretty much the same. Nothing really happened interesting-wise until we got to this x-axis reflection. Because before, we always said that this was decreasing until we hit the vertex, and then it was increasing on the parent function. However, now it's the other way around. It's increasing, so you'd be riding your bike up the hill. You get to the top, So it's increasing. So we would say it's increasing from, well, remember this graph goes on to infinity. It keeps getting wider and down further. So really we would say any value of x that is less than or equal to, and I really think it's less than, but anyways, less than or equal to, well, an x position of 0, because it didn't go left or right. It's still right on the y-axis. Had I shifted the whole graph, had this been over, we would have to talk about it. Let's just go to right there. We'd have to say, well, it does this all the way up until the x value of 3, but it doesn't do that. So, and then it decreases. We would be riding our bike from then all the way down. This would just be a crazy ride down the hill. So it's decreasing. X values would be decreasing from that 0 position onward. All right. So let's kind of put a couple more pieces together on this. What happens when the negative is still there, but now we also add in the a value being different than 1? Because in the last problem, it was a negative 1x squared. In this case, it's a negative 2x squared. Well, think back to how the number sitting in the a position, what effect it had, especially with the last video. If the a value is greater than 1, it was stretching the function. And if it was between 0 and 1, such as 1/2 or 1/4, it was widening, also known as shrinking. So we can actually already say that this one is going to stretch by factor of 4. What else will it do? Well, we also see that the c value is a -1. So we could actually say that it goes down, and I'll just put an arrow down 1 unit. But yet there's even one more transformation. Let's plot the numbers. I already highlighted the fact that the +3 and the -3 are way off the graph, so we'll just go with the ones in between. So I'm going to go backwards to -2, and I have to go down to -9, which is right here. So that's in green. The next one in pink, I go backwards to 1, but I have to go down only to 3, to -3. After that, 0, -1, so it's right there. And then in red, it is forward 1 and down 3. And then in this, I don't know, teal color, I'm not sure what color this is, I go forward 2 and down to -9 again. So I end up this time with a graph that looks like that. Notice again, this one had a negative, and so it turned it upside down. It was reflected over the x-axis. And that's actually the transformation that does take place first. It takes the parent function and turns it upside down. Then it would stretch it. Notice that this is skinnier than the one above it, the parent. It's skinnier. So once we said it was going to be a stretch factor of, oh, hey, I wrote a 4, sorry. That's a 2. There we go. Sorry about that. Because why? Well, it's a 2 right there. We already said it went down 1. You can see that. It moved down 1. The vertex moved down 1. So the only transformation we needed to add was the idea of the x-axis reflection, which does change our increasing and decreasing. It increases. It's really difficult to ride the bike from basically negative infinity all the way the x's. As we get further out on the x, the graph is further down. So from negative, in any x's that are lower than, well, the 0 position. So any x's that are less than or equal to 0. I really don't think that the equal should be there, but I've noticed on the computer they left it. So I'm going to take it off. I don't really like it because at 0, it actually is flat. anyways. So then from 0 position on to positive x's, it's whoo. It's we're going downhill. The bike is going downhill, so it's decreasing. So we would say any x values that are greater than 0. All right. So highlights from this one. X-axis reflection, reflecting over the x-axis, happens when the a value has a negative in front. And that is the key piece to this lesson.